A very good morning, dear students. Hope so you all are fine. Welcome to digital classes under theme Samay 10 se 12 wala Har Ghar Bane Pathshala. So this is a chemistry period, and we are doing the structure of atom. Today we will study about the wave nature of matter and particle nature of matter. So let's start with the positive mindset. Today's thought is life is not a competition. Life is about helping and inspiring others so we can each reach our potential. So, dear students, the purpose of life is to serve others. However, when doing so, you should not expect something in return. Your intention should be to lessen other people's misery. Okay? And service to others should be sincere and done from the heart. Only then it is fruitful. Just I want to bring your attention toward this thing. You just think, do any trees eat their own fruits? No, this teaches us that human beings should not only use their mind, body and speech for themselves, but also serve others also. When you do this, nature in turn will reward you. So dear students, in this difficult situation, we should not think about the competition only. We should not use our mind to just pull others' leg. It's all about to share and care the notes, to help each other. So during this pandemic situation, just please share and care your thoughts, your notes, your knowledge with others also. So let's start today's topic with the recapitulation, as we have done in the last video about history of atom. In the history of atom, as we have studied about, the Democritus was the first scientist who coined the word atom. Then this in the structure, Thomson's model, Rutherford model, Bohr we will do now. Thomson's model and Rutherford model we have done. Now today we are going to start the story between Rutherford and Bohr. This is wave nature and particle nature are the two type of natures, which came after Rutherford's that drawbacks and before Bohr's model. Okay, so let's recapitulate the electric nature of matter. As we know, this is not visible that much. It is very small, so I have shared this page yesterday to you. Go through it. So this is all about the history. Now today we will study about the wave nature. In wave nature especially, we will talk about the nature of atom, nature of electron, proton and neutron in the atom. As we know that atom comprises three subatomic particles, that is electron negatively charged, proton positively charged and neutron no charge, in which proton and neutron are lie in between the nucleus and electron revolve around the nucleus. So the structure of atom is somewhere like this one, as you can see, in which nucleus is there, neutron is in the nucleus, proton is in the nucleus, and neutron and proton are known as nucleons, and electrons are revolving around the nucleus. Okay, so before going to start wave nature, let's talk about the atomic number and atomic mass. Now dear students, when we know about the electron, proton and neutron, we should know about the atomic number. Now concept of atomic number you have studied already in the junior classes. So number of proton present in an atom is known as atomic number. This was discovered by Moseley in 1913, and the sum of proton and neutron in the nucleus is known as atomic mass. So once again, what is the common difference between atomic number and atomic mass? Atomic number is the number of proton and atomic mass is the sum of proton and neutron. So let's discuss the atomic number. The number of proton in an atom is referred to the atomic number. It is denoted with letter Z, and elements are defined by the number of proton they possess. The atomic number of hydrogen is as 1. And atomic mass of an atom reside in its nucleus, as the mass of atom is practically due to the proton and neutron alone. Therefore mass number of an atom is the sum of the neutron and proton present in the nucleus of an atom. For example, hydrogen mass is 1. Only hydrogen is the atom in which there is no neutron. That's why the mass is 1, and only the hydrogen is the atom whose atomic number and mass number is equal. Okay, so this is also exceptional. So now atomic number and mass number conclusion we will discuss as in a representation of atomic number and atomic mass in the structure. So atomic number is what? It is the number of proton present in the nucleus or the number of electron in the neutral atom. In case of neutral atom, okay, only electron and proton together in a nucleus are called nucleons. And what is mass number? It can be denoted with designated with A, capital A, and the number of proton is equal to number of neutron. Okay, as in atomic structure we can write like this. X is the symbol of any element. Suppose hydrogen is there, so H we will write, and on the top, on the head, the mass number we will write, and on the bottom atomic number we write. Atomic number can be represented with Z and mass number can be represented with A. Okay, so next definitions, as we know about the neutron, electron, proton now, so we can find some more new definitions, we can understand some more new definition. First is isotope. As in isotope are the atom of the same element which different mass number. All those atoms in which same element is there, on the all those element which has same atomic number but different mass number is known as isotope. And for example, in case of hydrogen, protium, deuterium, tritium are the three isotopes of hydrogen. As in case of protium, there is one number of hydrogen and one number of mass number is there. Deuteron, where hydrogen atomic number is 1 but mass number is 2. In case of tritium, hydrogen atomic number is 1 but mass number is 3. Similar way, what is isobar? Isobar is the atom of different element with different atomic number. Now it is opposite to the isotope. In case of isotope, there was same atomic number but different mass number. In case of isobar, there are different atomic number but same mass number. Okay, so for example, in calcium atomic number is 20 but mass number is 40. But in case of other argon, atomic number is 18 but mass number is 40. So because of same mass number, it is called isobar. Third is isotone, atom of different element which contain the same number of neutron. Atom of different element which contain the same number of neutron. However, both the atomic number or mass number are different. Same number of neutron but atomic mass and atomic number is different. For example, carbon 6 atomic number but mass number is 14. As we know, 6 carbon, 12 mass number is there. In case of nitrogen, there is 7 atomic number, 14 is mass number. But in case of isotone, there is one extra electron, neutron. Because of that, the mass number becomes 15. Similar in the oxygen. Okay. So application of isotope in our daily life, isotope can be used in uranium. It is used as a fuel in nuclear reactor. An isotope of cobalt is used to treatment of cancer. And isotope of iodine is used to treatment of goiter. Once again, the isotope of uranium, it is used as a fuel in nuclear reactor. Isotope of cobalt is used to treat the cancer, and isotope of iodine is used to treat the goiter. Now, in real sense, we need to study about wave nature. Dear student, as we know, we have divided the history of atom in basically three parts, that is the electric nature, wave nature, and the particle nature. In electric nature, we have studied all these electron, proton and neutron, and J.J. Thomson, Rutherford. Now we are talking about wave nature of electromagnetic radiation. According to Newton, it started the long back history, right from the Newton. According to Newton, light was regarded as a stream of particles. It is regarded as the stream of particles. So, in corpuscle of light theory. Okay, in the theory of corpuscle of light, the particle nature could explain certain phenomena such as reflection and refraction associated with light, but at the same time it failed to explain two more important phenomena, that is interference and diffraction. So because of that, the corpuscle theory of light was replaced by wave theory, that is given by C hyphen. And in 1870, James Clerk Maxwell, very important, James Clerk Maxwell stated that light, X-ray, gamma ray and heat, etc., these all things emit energy continuously in the form of radiation, or you can say wave, and the energy is called radiant energy. Then he used this energy, the light, he used the word light, replaced the word light into radiant energy. And then further, these waves are associated with electric and magnetic field, because in these waves electric and magnetic fields are there, and therefore this is known as electromagnetic radiations or electromagnetic waves. Okay, so this is all about the wave theory. And the C, in electromagnetic spectrum, why the word we are using now electromagnetic spectrum? Number one, because of the following characteristics of electromagnetic waves, we are using it. Its name is electromagnetic spectrum, as they emit energy continuously in the form of radiation. They emit energy continuously in the form of radiation. Second, the radiation are associated with electric and magnetic field which oscillate perpendicular to each other. So it means that electric and magnetic field are perpendicular to each other. You can see a small picture is given here. It is showing that blue color and red color path. So red color is the suppose electric field and the blue color is magnetic field. So you can see here very clearly electric field is perpendicular to the magnetic field. So these are called electromagnetic spectrum. This is the behavior of electromagnetic spectrum. So in visible light, we are talking about light. Now dear student, don't be confused. Visible light, radiant energy, electromagnetic waves, all are same things, but just as per the different time, different scientists have used different term. So visible light is a small portion of electromagnetic radiation spectrum detected by our eyes, which is called visible light. Electromagnetic radiation including radio waves, microwaves, and X-rays, described as a wave traveling through space. There are two components to electromagnetic electromagnetic radiation and electric field and magnetic field. So basic thing is what thing is making electromagnetic spectrum, or what thing is making a wave, what thing is making a light. There are two things that makes wave, that is electric field and magnetic field. So let's discuss some more about the wave nature of light. In the wave nature of light, we need to discuss about some important definitions. Like first is wavelength, which is denoted with lambda. It is the distance between two corresponding point on a wave. It is the distance between two corresponding point on a wave. Mean it is the distance between, if we will take like this way, this is a wave, so this is the distance between this to this is called wavelength. This point to this point, this is called wavelength. And amplitude is what? It is the size of height of the wave. It is the size of height of the wave. This is, if this or this size we will talk, this is the size of height of a wave, that is called amplitude. Frequency, it is denoted with mu v. It is the number of cycle of the wave passing a given point per second. If I will tell 1 second is the wave is reaching from here, this point to this point, it means that how many cycle is there, how many waves are passing, 1 2 3 4, like this way. So it means that this is called frequency. Velocity is, next is velocity, which is denoted with c. It is the linear distance traveled by a wave in 1 second. It is a linear distance traveled by a wave in 1 second. So next point is wave number. Wave number is mu var. It is the number of wavelength which can be accommodated in 1 centimeter length. If we will take the 1 centimeter from here to here, so how many wavelength is traveled, how many number of wavelength is there, that is called wave number. So we have discussed wavelength, amplitude, frequency, velocity, wave number. These are the 5 basic definition. Once you know the definition, then you can discuss about the next formula. So we are going to find out the relation between lambda and wavelength and wave number. So there is a relation, as you can see, c is equal to lambda into v. C is equal to lambda into v. Velocity is equal to wavelength into wave number. So how to derive? V is equal to c upon lambda. It means that frequency is equal to velocity upon wavelength, and wavelength is equal to 1 upon wave number. Therefore therefore frequency is equal to velocity into wave number. So this is given in your book also, once see the relation. So next is electromagnetic spectrum. What is the exact meaning of electromagnetic spectrum? So definition is the arrangement of different electromagnetic radiation in order of increasing wavelength or decreasing frequency. If we have discussed, as we have done in the previous, we have discussed that different types of electromagnetic waves differ with the respect of wavelength and frequency. Mean different type of electromagnetic waves have different range of wavelength and frequency. Since the product of these velocity of light is constant, this means that greater the wavelength, smaller will be the greater the wavelength, smaller will be the, yes please student, smaller will be the frequency. Okay, as again the formula is written, lambda is equal to 1 upon v. What is the meaning of this? If the wavelength is increasing, frequency will decrease. As it is not directly, it is inversely proportional. Okay, lambda is inversely proportional to 1 upon v. It means that more the lambda, less will be the v. Getting the point? So on the basis of this, we can find out that the wavelength of electromagnetic waves increase with the decrease in it will increase with the decrease in frequency. Okay, so this is the definition of electromagnetic spectrum. Like increase in wavelength, decrease the frequency. Increase in wavelength, decrease the frequency, and it can be categorized in term of wavelength or frequency. You can see this is the value. If I will see in physics also you have studied, I think 10 raised to power 24 to 10 raised to power 0. It means that energy is increasing toward this direction. As energy is increasing, frequency is decreasing. As you can say 10 raised to power minus 16 to 10 raised to power 8, it is decreasing. So we will see how the rays, gamma rays, X-rays, UV rays, visible rays, infrared rays, microwave rays, FM rays, radio waves, AM rays, and long range rays. So we will discuss about this, especially this visible range. This visible spectrum is although how we are going to see the colorful world. That is because of visible spectrum from this point to this point. It is simply 400 wavelength to 700 wavelength. This range of 300 wavelength is called visible spectrum, which is giving us vibgyor, indigo, blue, green, yellow, orange, and red color. That is called rainbow. Okay, so this visible range is rainbow. So this is all about electromagnetic spectrum. Once again, from the book you see. So this is all about waves nature. In wave nature, we studied about simply we have discussed about if we will see what we discussed wave nature. Once again, revise. So from here we have discussed that light is replaced, the word light is replaced in the wave, and the wave is replaced again in the electromagnetic wave, as electromagnetic wave have two things, electric field and magnetic field. From there we come to know the nature of wave, how wave is going to be move, and as wave is moving, so some wave is fast, some waves are low, I can say slow. So this is because of these range, wavelength, amplitude, frequency, velocity, and wave number. There is one relation between wavelength and frequency, that is lambda is equal to 1 upon mu naught. So because of that, increase in wavelength, decrease the frequency, that is making electromagnetic spectrum. This range is called electromagnetic spectrum, and we are discussing especially in electromagnetic spectrum the visible range, okay, which is making vibgyor in future. So now particle nature of electromagnetic radiation, which is also known as Planck's quantum theory. Why it is known as Planck's quantum theory, that explanation we will discuss. So electromagnetic radiation, in 1900 Max Planck studied black body radiation and realized that to explain the energy spectrum he had to assume that energy is quantized. Quantized means we can write the in number, energy can be write in the number, and light has particle character. Okay, so according to Planck's quantum theory, E is equal to hb, which is very famous theory. Let me explain you again the particle nature. The electromagnetic theory of radiation given by Maxwell regarding radiant energy as continuously flow of energy in the form of waves. If when the energy is continuously flowing in the form of wave, that time we can tell it the radiant energy. We can use the word radiant energy, and if it is continuously moving, that's why it's called particle nature. So this theory no doubt explains certain phenomena associated with light, but at the same time it failed to account for a new phenomenon. Suppose, for example, the nature of radiation which are emitted by black body are called black body radiation. Next slide we will discuss the ejection of electron from the surface of certain metal, then light radiates like, which is called photoelectric effect. These two concept we need to study in the Planck's quantum theory under particle nature. The spectral line are emitted by certain element, this is known as line spectrum. This also we will discuss. And in order to explain these all things, Max Planck in 1900 put forward a theory known as Planck quantum theory. Quantum word is the number. It regards electromagnetic radiation made up of particles. It shows that the electromagnetic radiation is made up of particles. One thing is, dear student, we come to know electromagnetic radiation is having wave nature, as it is moving like wave, in which electric field is perpendicular to magnetic field. Second thing, electromagnetic radiation is a particle nature, okay, which was further extended by Einstein in 1905, in which the main point of theory was the radiant energy is emitted or absorbed continuously in the form of small energy packet. It means that the radiant energy is emitted and absorbed in the form of small energy packet, which is called quanta. In the light, these energy packets are known as photon, and the energy of each quantum is directly proportional to the frequency. E is directly proportional to V, that we will discuss in next slide. E is directly proportional to V, and if E is equal to hb, as h is becoming Planck's constant, the value of Planck's constant is 6.626 into 10 raised to the power minus 34 joule per second. Okay, so what we understood, electromagnetic radiation, it means that Planck has proved that the electromagnetic have particle nature also, as it is emitting and releasing the energy also in the form of quantum, in the form of set of energy. Okay, so he found one relation, E is equal to mu and E is equal to hv. E is direct proportional to V, and h is the constant, which is called Planck's constant. So in Planck's quantum theory, higher the T, shorter will be the wavelength. Mean more the temperature, less will be the wavelength. It couldn't explain with the classical physics, so it explained with the help of black body radiation, and photoelectric effect. Okay, so what about black body radiation? What do you mean by black body radiation? Before going to move the black body radiation, there are some numerical related to Planck's quantum theory, or you can say Planck's formula. So please go through that NCERT book as from the PDF that I'm going to share. So now let's move the black body radiation. What is black body radiation? It is explained by the Planck's quantum theory also. An ideal black body may be defined as a perfect absorber and a perfect emitter. As we said, particle nature is absorption and emission. So a perfect absorber and perfect emitter of a radiation, which means that it emit and absorb radiation of all frequency which fall on its surface. That is called black body. As you know that black body is very good absorber of electricity or light, okay, or energy. As it is receiving energy, a black body absorb all the radiation that are incident or falling on it. However, when such a body is heated, once its body will hit, it emit energy in the form of radiation also. When a black body such as iron rod is heated in a furnace, let's take an example of iron rod. When we are going to heat the iron rod in a furnace, it undergoes a series of changes in color. You can see the change in color. With the temperature, it initially become dull red, then it become more and more red as the temperature increases, and the red color change into yellow in the end, and then to the white, and finally it become blue at very high temperature. These changes in color, these observation of changes in color is agreement with the wave theory of radiation, since according to this theory the heat energy supplied must increase with the intensity, and some color, red, black or black body is not expected to undergo change in color. So it means that with the change in temperature, the color will also change. So one relationship they have, as I told in the Planck's constant, E is direct proportional to V. Okay, so after this particle nature of light, so particle nature of light is known as photoelectric effect also. You know, photo mean light, electric mean radiations, and effect mean the relation between how photoelectric effect is there. You know very well, wherever electricity is passed, you can see the light. As you can take the example of your bulb, if it is electrons which is moving and those electrons are generating light, so that kind of effect is called photoelectric light. And how the light is emitting mean reflecting out, that is due to the threshold energy, and it is first recognized by, or you can say discovered by, Hertz in 1887, when a beam of light is of certain frequency strike the surface of some metal, then some electrons are emitted or ejected from the metal surface. It is very simple, dear students, how you can see the colorful things. Once the light will fall on any object, some electrons are emitting from the outermost surface. Because of those electrons, we can see the light. Okay, can you see the colorful things in the dark room or in the night? No, because some light is not going to fall on any object. The moment light will fall on any object, it will emit some of the electrons from the surface of metal under influence of the striking photon, and we can see the light. So photoelectric effect is light striking of metal surface generating photoelectron. The light's energy is transformed to electron in metal with sufficient energy. That energy is break free the electron from the metal, and electron given more energy move faster. Which electron will get more energy? They will move more faster and have high kinetic energy when they leave the metal. Secondly, photoelectric effect is used in photocathode. What is experimentally he did? He took a photocathode and he allowed some light to fall on that object, and he saw some colorful light that is reflecting, or that light he said it is that's why he proved that the light is also having particle nature. What was his observation in photoelectric effect? Certain important observation he was made in the connection with the photoelectric effect. The first, only photon of light of certain minimum frequency called threshold frequency, electron will emit only from the outermost surface when it will reach to the threshold frequency. It is the minimum frequency required to emit the electron. If energy of outer sources is less than the internal energy, then electron will not reflect from the metal. It can cause the photoelectric effect when it will reflect, and the large of intensity of photon may be there. The value of V0 is different for different metal. The kinetic energy of the electron which are emitted is directly proportional to the frequency. Yes, this is true. More the energy, more will be the kinetic energy. The number of electrons that are ejected per second from the metal surface depend upon the intensity of striking photon. This is also how fast the light is striking on the object. that much faster the electron will eject. This is the simple relation. So this explains the photoelectric effect, in which energy of incident photon means falling photon, is equal to work function plus kinetic energy of emitting electron. So this relation has concluded that if the energy of the incident photon is less than the threshold energy, no electron will be emitted. Again, if the energy of the incident photon, falling photon, is less than the threshold energy, no electron will be emitted from the surface. Second, if the incident photon have energy equal to the threshold energy, electron will be just released from the metal surface, not emitting. Third, in case of incident photon have energy more than the threshold energy or work function, the emitted energy will acquire some chemical kinetic energy. It means that it will move more faster than the as per the incident light. Okay, so dear student, this is all about wave nature and particle nature. So let's conclude this session and we'll see upcoming topic. This wave and particle nature came from the drawback of Rutherford. And what was the drawback? It couldn't explain the gravitational force in nature. It could not explain planetary motion under the influence of gravity. It could not explain Maxwell's electromagnetic radiation property. It could not explain quantum mechanics as a whole. Because of that, Bohr was the next person. He proposed that only special discrete orbits are allowed inside the atom, and while revolving electron doesn't radiate any energy. The subatomic particle in a nucleus is electron, proton and neutron. It was same. Valency is the combining capacity of atom. Once the Bohr has given this different orbital energy shell, so automatically valency topic will also come. Atomic number is the number of proton, mass number of the sum of the proton and neutron. Isotope of the atom are same element which have different mass number and same atomic number. Isobar, we did the atom which has same mass number but different atomic number. One was more isotone. Just recall what is the isotone. Yes, dear student, it has different neutron with the same atomic number and atomic mass. Okay, so hope so you enjoyed these videos, you understood everything. Just go through video again and again, just go through those PDF files which we are going to share. Okay, so then you can understand the concept in better way. So this is all about for today. Thank you for watching this video. Till our next video, please stay home, stay safe and take care of yourself. Keep enjoying the digital classes. Have a nice day. Thank you.